I want a Tesla P90D.
Tesla?
Yeah, the Tesla P90D.
The new one?
Are they good cars? They're overrated.
How much are those?
Dude, they're overrated.
600 horsepower and essentially infinite torque from zero.
Yeah, no, you're tripping.
No, that's what they have.
Yeah, I'm saying, but I'm just saying that's how they have it. Handling is quite fair. The weight transfer on Tesla's I'm acquiring two years.
Yeah, I don't think you're right. I don't think you can buy a car better than the weight transfer. Do you have any questions before you take off? No. You good? Cool. Questions?
How much?
Besides the fact that you're wrong about cars.
Dude, I think they made them like 30,000.
Yeah. It's been putting on
His car
the
model. Oh, it's 40,000?
Huh?
It's still pretty expensive.
Between what? They're different things. That's kind of like, what's the difference between cars and running?
I thought we were going to go over it.
Dude, all my friends have been buying them.
They're two different things. Okay, so if you want to do, like, I'll show you how malloc works. We'll talk about malloc is, and then we'll talk about structs and something else. Okay. All right.
Kia so much better than no. The name still. Who owns Kia? None of my friends. No, I meant like who's the parent company? Is it like Toyota or is it? None of my friends. Not enough. I don't know.
He said that the Teslas don't have good handling. And I told him that he probably couldn't buy a car that has better handling than Tesla, so it doesn't matter.
What?
The question's moot.
No, there's a Miata, there's an S2000.
No, Tesla is worse for the environment.
What? Oh, well, whatever. I was just talking about the fact that Tesla has 600 horsepower and has infinite torque, that's all.
That can't be true.
No, it's true.
No, I meant about what he said about the electricity.
I don't know whether or not.
I heard in Germany.
The lithium-ion batteries are.
I heard in Germany they have like excess electricity from renewable energy. They're paying people to use it.
That also sounds not true, but that's okay.
I read that.
Okay.
I swear to God.
Let's not talk about these things. Let's talk about other stuff. So, malloc. Let's do malloc first, right? So if I have an integer pointer, stuff, and I put a semicolon there, that means it's a pointer to an array or a single integer, correct? This is malloc. This is malloc's first, right? So this is a stuff pointer. It points at stuff. Does it currently point at anything?
No.
Well, it does. It points at garbage, right? But that's not useful for us. So if I tried to do something, if I tried to say, for example, stuff of 0 equals 3, I don't know what that's doing. It'll probably crash, because I don't know what that's doing. I don't know if that memory is valid. So if I want to have valid memory, I'll go in and malloc that space. So what I'm going to do here is I'm going to say stuff equals integer star, because I have to typecast the return of malloc. Malloc, size of an int, times some number, let's say 40. Semicolon. And what this does is that creates, or it allocates, it doesn't create, it allocates 40 integers worth of memory. Make sense?
Yeah.
So if you want to think about this in terms of 237 stuff, and 237 concepts, this here is an address. It's a pointer, it's an address to a location in memory. It'll have 40 integers. How big are integers in C? 4 bytes. So that means 4 times 40, it means that we're going to be pointing at 160 bytes worth of memory. When I say stuff of 0, that means the first element, or the first address, the first thing that pointer points at. If I said stuff of 0 equals 3, like so, that's saying the first element equals 3. Then I could say, for example, stuff of 40, well, 40 didn't work, let's say 35. 35 equals 10. That'd be the 36th element would be equal to the value of 10 now. How many bytes do I have to skip?
35?
Yeah, to get to the 35th one.
35.
So 35 times?
1.
Ah, right? So I don't skip 140, right? So I have to skip 140 bytes to get to the 35th element. Because I have to do 35 times the number of bytes per element, which is 4. But in C, I don't have to put that 140 in there. I just put 35. That's what we use malloc for. Malloc is for allocating memory. This malloc space is now on the heap. It is not on the stack. When this function finishes, that memory does not go away. The memory actually does not go away until you free it. So if you do not free that memory, that's called a memory leak.
Just judging.
So what exactly does the heap have?
So the heap has everything you want that isn't in a single function call.
So when you free it, what happens to it? It doesn't go away, does it?
It's given back to the operating system. So what malloc does, malloc actually goes and asks the operating system for memory. And so it goes and says, hey, can I have some memory? And the operating system goes, here, have some memory. And it gives you a pointer to some memory. When you free it, you're giving it back to the operating system. And the reason why this is true, let's suppose I have 10 gigs, 8 gigs of RAM on my computer, like they think these have 4 or 8 gigs of RAM, and I want to run my program. My program comes and says, hey, I want 25 bytes of memory. This operating system goes, here's 25 bytes, and it gives you 25 bytes of memory. Now, when it gives you those 25 bytes, no other program can access those, well, no other program is given access without explicitly asking for those 25 bytes by the operating system. So when Microsoft Word opens, it doesn't get those 25 bytes, so it doesn't mess with your memory. And so it gives it back with the free. When I free it, the operating system might give those 25 bytes to somebody else.
So otherwise, when you run task manager and you go to the process list, it has all those programs and all those kilobytes and whatnot, that is like memory allocation, for example, right?
So yes, those are all memory allocations by the operating system. And they're more than memory allocations. There's a lot of stuff going on. When you take the operating systems class, you'll understand better. It's all virtual memory. None of the memory you get in your programs are real.
So when you first call asterisk self, is it just an
So
address?
this is not a call, this is a definition.
So you're defining that it's a
Pointer.
type or?
Defining the type of stuff to be a pointer
it's
to
nothing?
integers. It's an address, it's a pointer.
And then once you call stuff equals
That.
spot right there in memory, then it changes the stuff above it?
This is the same variable, yes.
What does it change where stuff is pointing at?
It changes where stuff is pointing at.
Okay.
Yeah. So if you're familiar with 237, let's say that stuff is inside of A0. When I say int star stuff, all I'm saying is I'm using A0. Do I know the value of A0 before I put anything in it?
So I just know that it's, say, 8 bytes or whatever in addresses.
Right. All I know is that it's 8 bytes and it's some sort of garbage
Okay.
in there. And if I said, for example, down here, if I said, for example, move.long, pound, what was the value, 3 into A0 here? I don't know where that's going because I don't know what that value is. What happens here when you malloc is you go and you ask the operating system for memory. And this is kind of a magic call, and we haven't really talked about how that happens in 237. When you malloc, it's what it does is it gives you a return value of an address. And so
it has to go to the memory and find the spot where it has 40 bytes available.
correct. And it returns that spot in memory and it gives it back to you and it says, oh hey, that value is, I don't know, 6070. That's the address of those 40 bytes.
So I reckon you could do it in one line. Could you do it in one line?
Yes.
Yeah.
So then at A0 would be that 6070. And then when you do that move.l, that would succeed because those bytes are available. Does that make sense?
Yes. Thank you.
Yeah, and you can do this in one line by putting that malloc up there. By putting this malloc stuff up there. I just separated the two of them.
So you put that in one line?
Yeah, you can put that all in one line.
Can you make that without adding extra lines?
How do you mean?
Infinite size or?
No, you cannot make these infinite size. And so this is one of those things, like in Java, for example, when you say int array, integer array equals new int of size 10, you can't change the size of that array. Because once you malloc the memory, you can't change that malloc allocation.
So if you need more space, what can you?
You reallocate more memory. So let's suppose that I wanted to have more memory. So let's suppose the first time is I had the size of the int and I malloc 10 bytes. 10 integers, right? Now I know, oh shit, I need 12 integers. So what I do is I say, okay, int star other stuff equals an integer star blah 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 times 11 integers instead of 10. Then I have to copy everything from there to here. For int I equals 0, I is less than 10, I plus plus, other stuff equals other stuff of I equals stuff of I, like so, right? And then I can say other stuff of 10 equals some new value. That allows me to get my 11th value. What if I now need 12 things? I got to do it again, right? Is this a smart way to do that? No. That's what 310 is all about.
Oh yeah.
That's why this is a terrible way to do things. Why is it a terrible way to do things? 310 tells you why and how to fix it.
So you use the for loop to copy?
To copy, correct. I'm copying everything from stuff into other stuff. And then after I do this, I would say free stuff, because I don't need stuff anymore. And then I could say stuff equals other stuff. And now my original stuff variable is now pointing at 11 as opposed to 10, but I have to copy everything manually.
So
I have
that's
to
like four
allocate.
form though, right?
Huh?
Would that be four form or?
Yeah, this is a long algorithm. When you take 310, you'll be like, ah, geez. That's all 310 is about, is how to fix that problem. Yes.
This is kind of off topic, but what time tomorrow is the test? 12 or
10:30.
10:30 to 12:30.
12:30? And same room, right?
Correct. The red lecture room.
Beers after?
No, I have another test afterwards.
Here's after. Maybe next time.
Other questions?
Oh, I'm having beers after.
You're having beers. I'm drinking. Don't worry, I'll drink tomorrow night after everything's done. Questions?
Do you know yet how much is gonna be the extra credit for the assignments worth? Yeah.
No, I don't. It depends on the final grades, the distribution. If the grades are too low, then I bring everything up with the extra credit. And if you didn't do the extra credit, you don't get the points for it. So.
Can you explain this question? So ignoring the fact that C++ exists, what would you do? What would be the first step in writing C into an object-oriented programming language?
You would want to combine both values and function pointers into a single struct. That allows you to have a non-primitive data type that contains both values and functions that happen on those values. I know I explained this before you got here. And then you have functions that operate on that non-primitive data type. And then you would have to figure out how to do inheritance and polymorphism, which would be later. But really, the first step is combining values and functions, and that's the big concept of object-oriented programming.
Okay.
In Lua, we talked about like shallow copies and deep copies for tables. Are we going to need to know that to the final?
So the reason why we talked about shallow versus deep is because we wanted to get to the concept of deep copy, which then got us to the concept of object-oriented programming, which then got us to the concept of metatables. I don't think you need to know exactly how to do the difference between deep copy and shallow copy. Most languages don't do deep copies by default. You have to implement them yourselves. So long as you just you have the understanding of the difference between, say, a deep copy versus an object would probably be most important. Is that okay?
Yes.
Cool.
We do a rule set examples.
Sorry?
Question 5.
Oh yeah, we'll do one of those too.
Can I, just one little sentence with the rules. If it was like EPS, it just deletes.
It just means that it just disappears.
Yeah.
Okay. Let's do E goes to 1, E1, E goes to E0, and E goes to 1. Those are the three rules. Let's write some sentences.
Why not?
Just
never
logic.
know, dude.
First is impossible.
So now that's the question: is are they impossible or not? So hold on for a second. Let other people, let everybody kind of answer them on their own time first, and then
Okay.
we'll talk about it.
One question I have about this is that let's say you make it, but you only drop the E. Can you just drop it, or do you have to put the one because
What do you mean? Say that one more time.
if you're going to drop the E completely?
There is no, so this rule set does not have a drop the E completely.
But
That's what EPS means.
Okay, unless you have the unless you click on the one, right?
So the only way to get rid of the E completely is to drop the one.
That's the first one possible.
Right. So you're saying the first one's impossible.
Yeah, second one is possible.
Okay. So we'll talk about all this. Let everyone, that's what I'm saying. Let everybody do them for a second, and then we'll answer it again. Not everyone's the same speed as everybody.
Yeah, dude, chill.
Everybody's actually done. We're just waiting for you to catch up.
I'm sorry, I'm a god.
Stop it, God. Here's some nice stuff. We're doing that.
I'm trying to solve it.
Yeah.
Oh wow, this one
Okay.
black.
Yeah.
So let's do this together as a group. The first one is not possible, correct?
Yes.
So the first one is not possible. Why is the first one not possible?
Cannot get two ones on the
Cannot get two ones onto the right of a zero.
That means that all the ones with 2 1s on the right zero is wrong.
Okay.
Right?
So that's the way we're doing it. So let's think about. We're going to come back down to this one here, which may be interesting.
Second one's possible, third one's possible.
Can you
start with 2 E's and then get
Well, so you always want to start with just a single E. You always start with just a single letter. And so so the goal is you start with a single letter and you get down to the sentence, or you start with a sentence and you make a single letter. Right. Because you're saying this single E is the entire expression. And these are the rules that I can make expressions bigger. And so, for example, this is an expression. An expression can be expression one, or it can be something else. And so when you're doing context-free grammars, you have to get to one non-terminating rule. Either start with one non-terminating, or reach one non-terminating from the bottom. Either way. So the idea that we can't get two ones on the other side of a zero is an interesting
No,
problem.
we can.
Let's see if we can. So this is a one. This is rule one. This is rule 2, and this is rule 3. Let's see if we can do that first. So we'll say, let's apply rule 1. So if we apply rule 1, we get 1E1, right? If we apply rule 1 again, we get 11E11, right? If we now apply rule 2, we get 11E0, E011. There's two ones to the right of a 0. So it's not true that we can't get two 11s. Yeah, and that's the reason why I said that's going to be the interesting case. See, this one up here we cannot get, right? And so the reason why we cannot get that one is that there's no application of rules that allows us to make that sentence. So you're correct about one not being possible. So one is not possible because we can't say, if we apply rule 1 and then we apply rule 1 again, which is get us the two ones, we can't get rid of that E in the center.
If there had been a fourth one with E to the EPS.
Then it would have been possible. Correct. So if we had a fourth rule E to EPS, this would be possible, but since we don't have that rule, it's not possible. All right, let's look at number 2.
Yeah,
So
possible.
the claim that number 2 is also not possible.
It is possible.
It is possible. Okay, it is possible. So we say if we apply rule 1, right, we get 1E1. So we start at E every time. 1E1, right? And then we apply which rule? 2. So we get 1E01. And then we apply 3, and we get 1101. Questions? Everybody okay with that?
Yes.
Yeah?
Wait, I
Yes.
think something like it. There's more than one way to do it? Or just no?
That's possible. There might be two ways to do it.
Can't you just apply the rule 1 twice?
So if you apply for number 2,
Yeah.
so if you apply rule 1 twice, you get 1E1. That's the first application. The second one is you get 11E11. And that's not the second one.
Why do you get one? Oh, because it's, oh, okay, I get it, I got it.
Cool. So the second one is, there's definitely possibilities that you can get it both two different ways. So I don't know, can any of these be done two different ways? Not that I see. Let's see if we can come up with one that can be generated two different ways and see if that is possible. I don't even know if we can with this rule set. Some rule sets you can, some rule sets you can't. Let's try the third one. Can we do the third one?
Yes.
Yes, and so this would be application of rule 2, which would be E0, and then we'd apply rule 3, and we get 1, 0, and we're done. So that is acceptable. Rule 3, or 4, sorry, number 4. Not possible? So if we apply rule 1, we get 1E1, and we apply rule 2 to get the 0, and then we still have the E that we cannot remove with the 1. It's the same problem that we had there, right? So this is the same problem there. Rule sentence number 5, not possible. So this is not possible. And we have the same problem where we're trying to get 2 1s onto the right-hand side of there of that 0, and so we can either apply rule 1 twice or rule 1 once and then a rule 2, and either one of those gives us that 1 1 with the 0 on the left of it. That was the one that you were trying to say is impossible. However, number 3, if we apply rule number 1 and then we apply rule number 1 again, sorry, not number 3, the last one there. When we apply rule 2, and then we apply rule 3, we get that guy right there, which is the last one. So the last one is valid. Okay, so can you construct a sentence that has more than one set of rule applications to the goal using this? I don't think so in this one. I don't think this rule set allows for it. To have 2 different set of rules that generate the same sentence.
Yeah, I don't think this one allows it.
I don't think this one allows it yet. It's this one on the right-hand side of the E here that fucks you up.
Yeah.
All right, let's change this real quick. What I'm going to do is I'm going to get rid of these sentences. We're going to look at a different set of rules real quick. I'm actually just going to erase that 1 right there. And I'm going to change this to an EPS. Now that we have this set of rules, I'm not going to write one. I want you to write a sentence that has multiple sets of rules that apply that are the same sentence.
Thank you much.
Well, with this kind of rule, with these set of rules, you can't have one on the right side at all.
Yeah, but can you generate a sentence that has multiple sets of rules that generate that sentence?
So I think this is going to be pretty hard.
0, 1, 1, 0.
0, 1, 1, 0? Just 1, 0? I think 1, 0 is probably even easier. You are correct, though. The answer is, with this set of rules, I think any valid sentence has multiple rule generations. So let's do the simplest one, and then we'll see yours as well. So if we just start with 1, 0, right? What's the first rule set? Rule 1? So we go from E to 1E to rule 2 to 1E0 to 1 EPS 0, which is 1, 0. So that's the first sequence. The second sequence would be
2.
Rule 2, which would be E0. And then rule 1, which would be 1 E0. And then rule 3, which would be 1, 0, right? So there's 2 different trees that generate the same sentence. Yours was 1, 0, 1, 1, 0. I don't think that's possible. That's not a valid sentence.
1, 0.
Oh, just 1, 1, 0? Just like that? Yeah, okay. Now this one has even more trees. How many trees generate that sentence? This one has 2 trees that generate that sentence, 1, 0. How many trees generate that sentence?
2. You had
1, 2, 2, 1, 1, 1, 2, 1.
2? A lot?
You can do 1, 1, 0, 1, 1, 2.
So let's look. So you can say you're going to say rule 1, rule 2, which gives us 1E, 1E, 1E0, which gives you the 110, the 3, right? Then what was the second one?
I can do 2, 1, 1, 3.
2, 1, 1, 3, which gives you the 0E, sorry, the E0, the 1E0, the 1, 1E0, which would be, and then the 3, which is 1, 1, 0, okay?
You can do 1, 2, 1.
Yeah, 1, 2, 1, 3. So 1, 2, 1, 3, which would be 1, 1E, 1E0, 1, 1E0, 1, 1, 0. Then you also have, are there any other ones? No. No. So it's not 2. It's not a bunch. It's 3.
More than 2.
It's more than 2, you are correct. But I wouldn't say that's a bunch or a lot. Maybe several.
Well, you add more ones and zeros to the right or the left.
Right. So if I put another 0 over here, now I have even more trees. Now there's a bunch of trees. Now I think there's 6. If I put another 1 over here and another 0 over here, I think we go up to, I don't know, like 28 or 27 or something like that. I think it's exponential. Any other questions?
Can we try one with multiple, like E and A? Or?
Two different yeah. 2 different non-terminating symbols is the question. Alright, so 4 rules. Those are your 4 rules. 2 different sets of non-terminating symbols. So let me put some sentences up there for us to validate.
This is what I want. Find out all
Let's try all those different sentences.
You always have to start with an E.
No. You have to start with a non-terminating symbol.
The first one.
So the first one you're saying is not possible.
Yes.
Why is the first one not possible?
Yeah, no one.
There's no way I can just get a 1, right? I can get just a 0,
Yeah.
but I can't just get a 1. Because if I apply rule 3, then I'd get a 1t. If I start with an E and apply rule 2, I'd get a 0. I get 2 1s over there, so this is not possible. However, if I start with a t, I can get just a 0. By applying, if I start with a t by applying rule 4, that'll give me just a 0, so this is valid. What about the second rule?
Yes.
Right? So we start with a t and we apply rule 3 and then we apply rule 4, we get 1 0. So that's valid. About sentence number 4.
No.
So we say no. So if we start with rule t, we go 1, we apply rule 3 again, get 1 1. Then we can apply rule 4 and we get a 0. So that's 1 1 0, right? That doesn't work.
So the next one.
So if I start with an E, I could apply rule 1, which would be 1 1 t, and I could end with a 0, but that still doesn't work for me. I can't start with E with 0 E, so I can't do that one there. Sentence number 4 is not valid. What about sentence number 5?
Yes.
Yes. How many different sets of rules are there that generate that?
2.
You say there's 2. What are those 2 different sets of rules?
The first one. Apply rule
ET.
1.
So you apply rule, you start with an E, you apply rule 1. That gives you a 1 1 t. You apply rule 4, which gives you a 1 1 0. And you're done, right? And the other one is you start with a t, and you apply rule 3, 3, and 4. Those are the 2 that give it to you. Correct. Those are the 2 different rules that apply. Do we care which set is valid? No. So the answer is we don't care which set is valid. It's kind of like In natural languages or human languages, when we speak a sentence that is ambiguous, can anyone come up with an ambiguous sentence?
The ball fell.
What does that mean? Oh, okay. The ball fell. I don't know if that's ambiguous. You could say, for example, Scott flies is ambiguous. Does that mean that Scott ran really quickly, or Scott got in an airplane and flew, or Scott got in a helicopter and flew, or he threw a cat off a building, or what did he do to fly? Right?
He's sick. Poor Superman.
Or am I Superman? I'm not Superman. I wish I was, but I'm not. That'd be pretty fucking awesome. I probably wouldn't be here. Not saying that it is cool to be here, but if you were Superman, you'd probably be doing something else. All right.
That's one.
Not possible.
I have a off-topic question.
Oh, later. Sentence number 6 right here. 001. Can we do that?
No.
No? So if I start with, oh yeah, no. So why is that not possible?
Because you cannot put 2-0 on.
I absolutely can. If I start with an E, I apply rule 2 twice, I get 0, 0.
Yeah, then.
But then you.
The E basically.
But I can't get to the
Can't get to
the 1 on the right hand side. Saying I can't start with 0, 0 is not true. I can't end with a 1 is true though.
You could have been 0, 1, 1.
It could have been 0, 1, 1, 0, but I cannot end with a 1. Next sentence.
No.
Oh, that's interesting. Yes or no?
No.
No. So I actually thought this one was going to be possible, but I did it wrong apparently. You are correct. It's not possible. So if we start with an E, right? Yeah, if we start with an E, we get the 1, 1, T, and then from the T, we're boned, right? We can't get back out of there.
Or you could have gone with the 3.
Say that one more time.
You could have started with 3.
I could have started with the 3, done the same thing. Now we're boned. We're screwed everywhere, every possible. We can't get any of those things, right? That's unfortunate. Okay. Last one is also false. Why is it false? I can't get that 1 at the end. Though.
You said command that syntaxes have a lack of ENS rule.
EPS? Yeah, the EPS. Yes, often sentences there are often rule sets that don't have an EPS, and the reason why is because often most expressions can't simply disappear. So if you think about this in human language, if you look at most languages don't allow you to drop part of the sentence. So if you look at a human sentence, and you say, for example, English is subject, verb, object, right? I usually can't just drop the subject. So like if it's Scott kicks the ball, I can't drop Scott and say kicks the ball. Most languages don't allow that. That's the reason why not. Cool. Some languages do, like I use Japanese because that's the one that's weird. Japanese allows you to drop the subject. And so there's rules in Japanese grammar that allow you to EPS the subject. Other questions? Cool. Other questions entirely, or are we done?
Done.
Okay, he's done. He wants to go drink.
Yes. I got a question now.
Yeah.
So I'm gonna stop here. Actually, no.
Okay, this is an off-topic question now?
Yeah.
Yeah, okay.
Alright, who would win? Goku or Superman?
So the question is, doesn't matter, because you're essentially who wins, God or God. They're both effectively infinitely powerful. It doesn't. So the question's moot.
Goku is.
Huh?
He dies like.
Yeah, but he's infinitely powered. So.
Superman is not infinitely powered. You take it out of the sun, underwater.
Yeah. Except for Superman has the power of gaining any power he needs to win the fight. That's Superman's real power.
He said
Superman's forest population.
And Goku can't die because as soon as Goku dies, he goes to the spirit world and he's able to come back whenever he's.
Really?
Or whatever.
Yeah, who knows more about this stuff than I do?
Goku also has the power to achieve whatever power level he needs to beat any opponent. The answer is it doesn't matter because it's a stupid question.
Got him.
You read them,
All right. Done?
Yeah.
All right. I'll see you guys tomorrow.
Wait, we got one question.
What gave birth to the field of big data?
Functional programming.
So what paradigm? Paradigm. What paradigm? Giving birth